We have learned that the thermistor is a sensor that converts the change in temperature into a change in the resistance. And we have seen how we can find the relationship between the temperature and the resistance using the data sheet of the specific thermistor that you are working with. However, for continuous monitoring, like for example, the thermostat at your house, you want to continuously monitor, we cannot monitor the resistance because the data acquisition systems, including microcontroller, can only read voltage. So we have to convert back the change in the resistance into change in voltage. And to do that, nothing better, of course, than our magic Wheatstone bridge. This is the circuit that we use, and we understand now how this circuit works. And please, if you don't see the 4 videos about the Wheatstone bridge, you need to go back and see how they work. So what I did here, I connected here the thermistor with the Wheatstone inside the Wheatstone bridge. Now our thermistor, as we know, is around 11 kilovolt plus minus kilo ohm. So what I did, I connected 2 resistors in series, 1 kilo ohm. So this is what this leg is 11, and this is approximately 11, and the other leg is 10 and 10 kilo ohm. And when you look here to the voltage, it fluctuates around 39 millivolt, which is relatively a small voltage, especially that we know that for the Wheatstone bridge, for the thermistor, the change in the resistance is high. So now ideally we are in this situation where the Wheatstone bridge is balanced. So this is around 11 kilo ohm, 11 kilo ohm. So our thermistor is in R2. Okay, so this is 11 over 11, 10 over 10. So we are in balanced condition, and the voltage is around 0. Now, what will happen when I start touching here, this one, and start to heat it up? See how the change in the voltage? Now the voltage becomes even voltage in volt, not in millivolt. So this is why an error of 50 millivolt considered as very small to the change in the voltage. So now we have around minus 0.6 volt. Okay, now how this happens, let's go back here for the unbalanced conditions. Now this is my R2. Okay, so now my R2 start to decrease, because as we understand now, the thermistor, as you heat it, the resistance will start to decrease. So when this decreases, this becomes R3 times R2 become less than R1 times R4, so this becomes a negative number. Okay, so from this equation, we know V out, we know Vs, we know everything else except R2, so we can solve for R2. Once we know R2, we go back and using the data sheet, we will find the corresponding temperature. So this is how the thermistor is used for continuous monitoring. Change in the temperature is converted to change in resistance. The change in the resistance using the conditioning circuit, which is here the Wheatstone bridge, is converted to a change in the voltage, and then we can detect that continuously. Then we can go back and find R2, which is the thermistor here in this Wheatstone bridge, and then go back and find the temperature.